Hello students, and welcome to this lesson on sector areas. Our objective today is that we will apply area and circumference formulas to find sector arcs and areas using journal notes and practice problems. First, let's recall our area formula and our circumference formula for a circle. So the area of a circle is equal to pi times r squared, where r is the radius. We have two circumference formulas. So circumference can equal 2 times pi times r, or we can also say that circumference is equal to pi times the diameter, where this is the radius, this is the diameter. And remember, circumference is really just a fancy word for the perimeter of the circle. All right. Now let's talk about a sector. So a sector is the area between two radii and the connecting arc. Think about a pie slice. So if I've got my center here of my circle and I draw two radii, then the sector will be this area in between those two radii that is also contained by this length of arc here. So this will be an arc length. This will be a radius. And then this is itself the sector. So when we're talking about the area here, the area will be equal to n over 360 times pi r squared. And in this case, this n is the central angle in degrees. So really what we're saying is that some portion, some degree, right, of the circle will be used out of the total circle, which is 360, and then we're multiplying that by the whole. So this is really kind of a proportion that we're doing here. But let's go ahead and look at arc length again. So arc length is something that we are already pretty familiar with. We have our original formula where if we're given theta times r, where theta is in radians, it's as simple as having this formula. So let's say that instead of giving you something in radians, we give you something in degrees. Well, as you well know, we have to convert into our radians to be able to use this formula. So what we would say is we have theta times pi over 180, because that'll convert me from degrees into radians, times r. So this is if our theta is given in degrees. So make sure that you know what unit you're working in again. We're using our degrees and we're using our radians again. Remember, they're both just different ways to measure a central angle. All right, so go ahead and take your example strip. There's 4 examples on it and glue it into the next page. We're going to work on those now. All right, so for example 1, we want to find both the area and we want to find the arc length here. So we're just going to make a little bit of a separation from these examples. All right, so if we're looking for the area of the sector here, so we say that A is equal to, and we want to use our formula, right? So if we're looking for the area of the sector, it's n over 360 times pi times the radius squared. So it'll be, in this case, we're given our radius as 150, so we say 150 over 360. And then that will be multiplied by pi times r squared, which is going to be 19, because our radius is given as 19 squared. All right, so we will throw some of these numbers in the calculator, right? So we can combine, we can kind of rearrange it here. So it's 150 over 360 times, remember this is actually 19 squared over 1 times pi. So top times top over bottom times bottom. That's really important, guys. I really want to stress that here. That'll be a skill that will go into the future and be very useful to you. Make sure that you know how to do your fraction multiplication. So we multiply those two numbers together, we get this over 360, and then we can actually reduce this. So we're going to see that the area is equal to 1805 pi. We want to leave our answers in terms of pi right now, over 12, and then we want to make sure that we're using the right units, right? So this is an area, so we're going to say feet squared. All right, so that's our answer there. All right, then we're looking at arc length. So this is going to be L is equal to, and we fill our formula, right? So we're given degrees, so we need to convert into our radians. So we have 150 times pi over 180 times 19. So then L is equal to 2850 pi. Remember, we're not going to put pi in the calculator. We're going to put all the other numbers in the calculator and then leave pi out of the calculator, but we're going to leave it in our answer. And so L is equal to 95 pi over 6. And then this arc length, right, it's this linear motion here. So that's actually going to be a linear unit, so it's just feet. All right, so now for number 2, we do the same thing. So we have the area is equal to, we're given our degree and we're given our radius. So we can say 315 over 360 times pi times 8 squared. And so area will be equal to 20160 pi over 360. And so our area is equal to, after reduction, now remember, you can use your calculator here to do this reduction. If you do math, and then it will say frac. So you don't have to do this reduction by hand. After you plug this in the calculator, this fraction here, this if you put in 20160 over 360 into your calculator, and then you just press and you press enter, and then you press math frac, it should convert it into the lowest possible fraction form for you. So don't waste too much time doing this. In this case, it's a whole number, so you won't even necessarily have to do that. So you get 56 pi centimeters squared. All right, so for the arc length, you have L is equal to, again, it's given to us in degrees, so we need to convert. So 315 times pi over 180 times 8. And so then L is equal to 2520 pi over 180. And again, this is a little bit easier, so we won't necessarily have to use our math frac, but we have 14 pi centimeters. All right, so take about 2 minutes, see if you can, well, 2 or 3 minutes, see if you can do the next pair of problems. They shouldn't be any different than these two. So see if you can find the next answers, and then go ahead and continue the video to see the solutions. All right, so now we're going to continue. So I hope that you've worked through these two problems using those first two as a guide, and let's go ahead and do them together now. All right, so for example 3, we're going to see that the area is equal to, again, 270 and 13 are given, so we have 270 over 360 times pi r squared, and our r is actually going to be 13, so 13 squared. And so the area is equal to 45630 pi over 360. And so we get that the area is equal to 507 pi over 4 feet squared. All right, and then our arc length, that's going to be equal to 270. We have to convert again, times pi over 180 times 13. And so that's equal to 3510 pi over 180. And then L is equal to 39 pi over 2 feet. Again, you don't really need to reduce this by hand. You have a calculator. You can use your graphing calculator to reduce this. And then finally, let's do this last example. We have area is equal to, again, we have 315 now over 360. And this is multiplied by pi, and it's also multiplied by our radius, which is 11 squared. And so we get 38115 pi over 360. And so we get that the area is equal to 847 pi over 8. And again, feet squared. And then finally, let's do our last arc length. That'll be 315 times pi over 180, because we're converting into those radians, times 11. And then this is equal to 3465 pi over 180. And so my length is equal to 77 pi over 4. And of course, we need our units, which are feet. All right, very good. So now that you've finished all the examples, we have a little bit of a reflection, so go ahead and do that. So our reflection is, how is the arc length related to the circumference? So when we learn this arc length formula, there's actually a relationship that we can see between the arc length and their circumference. And I'll give you a hint. It's very similar to the relationship that we saw between the sector area and our area of the circle formula. So go ahead and compare those formulas. See if you can kind of figure out the relationship there. And then the second thing that I want you to do is tell me what a sector is. So those are your two reflection questions. They're probably going to take you about 5 or 10 minutes. So go ahead and get those done. When you're done with those, go ahead and get started on your homework. If you have any questions, let me know. Have a wonderful day. Goodbye.